So we're starting with number 15, exponential equations, common base, level 1. So let's click on that one. Okay, so it looks kind of crazy, but the clue is that we are going to solve it with a common base. So if you look at this crazy looking number, we just have to figure out what base we want this to be. And then if you look at the other side, we can see that there is a 6. Now the common base that we want is not always going to be the same base as the other side, but it usually will be, or that it can give us a clue to what we want. So in this case, we have 6. So let's try to see if 1296 can be written as 6 to the power of something. So I'm just going to go on my phone's calculator, and you guys can go on your phone's calculator as well to try to see what power I should raise 6 to get 1296. So 1296, as it turns out, is 6 to the power of 4. So what I'm going to do is rewrite this entire thing. I'm going to rewrite it over here just for space. 6 to the power of 3x plus 2 is equal to 6 to the power of 4 to the power of x plus 3. Okay, so I'm going to pause here and see if you have any questions so far. Let's keep going. So now I'm just going to keep this as the same. But with the 6 to the power of 4 to the power of x plus 3, remember that you can multiply these exponents. Multiply this. So 6 to the power of 4 times x plus 3. We're multiplying the exponents together. So this part remains unchanged. And then let's distribute the 4. So it's 4x and then plus 12. Okay, I'm going to pause here and see if you have any questions so far. Let's keep going. So now that we have them with a common base, all you have to do is just take the exponents and set them equal to each other. So the 3x plus 2 and the 4x plus 12. Literally just take those and set them equal to each other. I'm just going to rewrite that over here because I have space here. So now all we do is solve for x from here. Okay, so to solve for x, let's bring all the x terms to one side. So I'm going to subtract the 3x over there. Cancel out. We get 2 is equal to 4x minus 3x is x. And then we still have a plus 12. Then I'm going to minus 12, and I get, cancel out, x on this side and negative 10 on that side. And so our final answer is negative 10. Are there any questions? Okay. Save the photos. And I don't think you have to type in x equals. I'm just going to type negative 10. Okay, let's do a couple more on this category. Okay, so we get 3,125 to the power of x plus 5 is equal to 5 to the power of x plus 5. So remember, we want to force it to have a common base. So this is a crazy looking big number, but the clue to what common base it might be, not always is, but what it might be, is to take a look at the other side. We have a 5. So let's see if we can rewrite 3,125 as 5 to the power of something. So I'm going to pause my recording so I can use my calculator to figure out 5 to the power of what is 3,125. So we just found out that 3,125 is 5 to the power of 5. Literally just using a calculator to figure that out. So 5 times itself 5 times is 3,125. So let's rewrite this equation that we have over here. Instead of 3,125, I'm going to write 5 to the power of 5 in parentheses. Then to the power of x plus 5 is equal to 5 to the power of x plus 5. This part remains unchanged. The only thing we changed here is the 3,125. I rewrote it as 5 to the power of 5 because they are equal. So from here, remember that you can take your two exponents. Let me point to them. You can take these two exponents and multiply it together. So I'm going to rewrite that. 5 to the power of 5 times x plus 5 is equal to, well, that It's not how you write a 5. 5 to the power of x plus 5. So all we did is just multiply those two exponents. Let's distribute it out. 5 times x, 5 times 5. And then this part remains unchanged. Notice we haven't changed anything on that side. Okay, pausing here, are there any questions? Okay, so now that we have a common base, this being the base, the 5s, because they're in common, they're the same now, we can set our exponents equal to each other. So I'm going to highlight our exponents, and those are going to be equal to each other. So 5x plus 25 is now equal to x plus 5. I'm going to rewrite that up here because it's where I have space. But all we did now is just take the exponents, set them equal to each other, and we can solve from here. So to solve from here, I'm going to bring all the x terms to one side. So I'm going to minus x. Those cancel out. And then we're just left with 5 on this side. 5x minus x is 4x, and then the plus 25 just comes down. Okay, now I'm going to take the 25 and subtract it over. We get 4x, those cancel out, equals negative 20. Then we're going to divide by 4 to get rid of the 4 that's being multiplied. Because x is being multiplied to 4, you're going to divide by 4 to cancel that out, because multiplying and dividing are opposites. We get x equals negative 5. And so this is our final answer. Are there any questions? So I'm going to save this and enter negative 5 into the answer box. Cool, let's do one more. All right, so for this one, it says 256 to the power of negative 5 is equal to 1024 to the power of x plus 1. So remember, we want to solve it by looking for a common base. And so this one's a bigger number, so maybe, just maybe, we can rewrite it in terms of 256 to the power of something. But let me show you why we cannot. So let's see. 1024, can that be written as 256 to the power of something? I mean, it can, but like it's not going to be easy that way. So 256 squared, let's take a look at what that is. 256 squared is equal to 65,536. So even if we just take it to the power of 2, it's going to be far bigger than 1024. Like 65,536 is just not quite what we're looking for. So maybe we need to rewrite this one in terms of another common base. So you just have to think about what common base can both of these have. And you can test out a few numbers. So you can test out maybe 2, maybe 3, maybe 4. I am going to test it out with the number 2 just because they're both even numbers. So let's try 256 is equal to 2 to the power of something. And then we're also going to try 1024 is equal to 2 to the power of something. And let's see what those somethings are. I'm going to pause the video so that I have time to use my calculator to figure this out. All right, so resuming recording now. We found out that 256 is equal to 2 to the power of 8. And we also found out that 1024 is equal to 2 to the power of 10. And remember, I tried the base of 2 because I looked at both of these numbers and I was like, okay, they're even numbers, so possibly 2 can be a base for them. And I tried it out. If it doesn't work, you could also try 3 to the power of something, 4 to the power of something, and 5 to the power of something. And then you can figure out which base they have in common from that. But in this case, we found out that they both are 2 to the power of something. So let's rewrite this. Instead of 256 to the power of negative 5, I'm going to write it as 2 to the power of 8 to the power of negative 5. And instead of 1024, I'm going to write 2 to the power of 10 to the power of x plus 1. So I just replaced the 256 and the 1024 with their equivalent values, but now their equivalent values have the same base. They have a common base now, and that base is 2. So then remember that with these exponents, you can actually multiply it. So I'm going to rewrite over here just because that's where I have space. But for these exponents, 8 and negative 5, I'm going to rewrite it. Actually, I'll just rewrite it that I'm multiplying it. I'll multiply it out in the next step. but I really want to emphasize that you just multiply the exponents. Okay, so now let's actually multiply them. Negative 8 times 5 is negative 40. And then 2 to the power of, let's see, 10 times x, 10 times 1. Just distribute it out into the parentheses. And so now that we have this with a common base, both of them have a base of 2, then you can set your exponents equal to each other. So negative 40 is equal to 10x plus 10. And then we can solve for x. So I don't need to move any x's to the other side because there's only one x term. All I have to do is subtract 10, get negative 50 is equal to 10x, and those cancel out. Then you're going to divide by 10, those cancel out, you get x is equal to negative 5. So this will be our final answer. Let's go ahead and enter in negative 5. Okay, so I think that's it for this video. Let's go on to the next category.